Now that we know how to identify the mechanical axis of the lower extremities, analyze the deformity, and pick the bone to correct, it is time to learn how to draw the axis lines that will help you find the apex of the deformities. To do so, we're going to start with analysis of tibias in the frontal plane in single level deformities. For this talk, to be noted that I have no disclosure and I will not be discussing any off-label or investigational uses for products or devices. So the first thing to do for the ABC is to identify and locate the apex. To find that apex, you first need to draw a proximal axis and a distal axis of the tibia. It's very important to understand that for this step, you are to erase the previous lines that you've done in the map portion of the analysis, and you are going to start with fresh lines. So the tibia is divided into a proximal segment that is above the deformity and a distal segment that is below the deformity. There exist three strategies to find the proximal axis. We have classified them in order of preferred strategy. The first one is to use the presence of a normal femoral mechanical axis proximal to the defect. The second one is to find a mid-diaphyseal bisector line of the proximal tibia. And the third one is to recreate a normal MPTA that matches either the normal side or a population normal. Our preferred strategy is to use a normal femoral mechanical axis. This can be done if there is a normal JLCA and in presence of a normal LDFA. The objective is to ensure the alignment of the hip, the knee, and the ankle. So when do we use a mid-diaphyseal line? Well, we can only use it if we cannot use the femoral mechanical axis proximally, so if the femur is abnormal, and if a normal MPTA is created by the intersection of the joint line and that mid-diaphyseal line. When can we use the create your normal MPTA strategy? When the other two strategies are unavailable, when the deformity is very close to a metaphysis, and when the MPTA resulting in a mid-diaphyseal line is abnormal. Let's go over a few examples. In this example, the patient has a normal JLCA and a normal MLDFA, and thus the normal femoral mechanical axis strategy can be used to find the proximal axis of the deformity. In the second example, where we do not have a femur proximal on that X-ray, well, we cannot really use this strategy number one. And to verify if a normal MPTA is created with that mid-diaphyseal line, in this case, we have an MPTA of 90 degrees, which is within normal limits. Thus, strategy number two can be used. However, should there be an abnormal MPTA proximally, it means that we're in the presence of a hidden deformity or a non-obvious deformity, and thus the mid-diaphyseal cannot be used. For example, in this X-ray, we do not have a femur to draw a normal femoral axis, so we decided to draw a mid-diaphyseal line and to verify the MPTA created, and that MPTA is 75 degrees. In that case, we default to strategy number three, where we have to create a normal MPTA from the center of the knee and down as our proximal axis. Why here did we pick 87? It's either because it matches the other side or it's because it's a population average. This slide summarizes the three different strategies to find the proximal axis. Once that we found our proximal axis, it is time to find the distal axis. There are only two strategies to find the distal axis, as there is no long bone below that could be used to find our mechanical axis. In this situation, we can use a mid-diaphyseal line if a normal LDTA is created distally, or we can create our own LDTA using the normal side or the population average. This example shows that we can only use a mid-diaphyseal line if a normal LDTA is created by that mid-diaphyseal line. However, if this mid-diaphyseal line creates an abnormal LDTA, we have to default to the second strategy and to draw a normal LDTA. In that case, you subtend a line from the center of the ankle in the joint orientation with an LDTA of 89. And here we pick 89 either because it matches the other side or as it is the population average. This slide summarizes the two strategies you can use to find the distal axis.